Hi everyone, so this is the last of the videos on domains. So there's only two examples because this first example will cover most of the things we will need to know about radicals, and then the second example will give us one special case we need to really worry about. So, and again, we're going to do a bit of side work to come up with the answer. So we're going to take the part under the radical and do some side work with it. And so it's not very hard side work with these type of equations. If the part under the radical gets more complicated, then we're going to have to lean on some of our algebra skills to figure it out. But we're not interested in such more complicated examples in this section. So what we're going to do is we're going to take this 3x minus 1 that is under the radical sign, and we're going to set this greater than or equal to 0. Just remember, we can only take square roots of things that are 0 or positive. So the equal sign will give us the value of x that equals 0, and then the inequality will give us all the values of x that will make this expression greater than 0. So we solve this like any other linear inequality. We're going to add 1 to both sides. And this will give me, those cancel, and give me a 3x is greater than or equal to 1. And dividing both sides of the equation by 3, we get x is greater than or equal to a third. So our possible solutions in this case are the following. You can write it in words, all real numbers with the property that x is greater than 1 or equal to 1/3. The property x is greater than or equal to a third. We can also write this in set builder notation, so we're going to use our weird little bracket here, and this will be the set of x such that x is greater than or equal to 1/3. And you may have seen I wrote a vertical bar before. Instead of writing a vertical bar, you can also write this with a colon. It means exactly the same thing. And then finally, we can also write this in interval notation. So we'll use a closed bracket because we have the equality sign, and this will be 1/3 to positive infinity. And so these are all possible solutions to this equation. Or all possible ways to express the domain of this function up here. So let's. Well, I guess I call this a function, but I didn't put an f of x in here, so now it's a function. Before it was an expression. So again, I'm going to need to put an f of x in here to talk about a function. So in this example, we look at f of x equals x plus 3 over x minus 1, and we want to see where this is defined, so what is its domain. And again, we're going to do a little bit of side work. So we're going to look at this part under the radical and do some side work. But unlike our previous side work that we did, we have to think about the fact that the radical of x minus 1 is in the denominator. So in this case, instead of setting x minus 1 greater than or equal to 0, we're just going to set x minus 1 greater than 0, because if we were to allow equals to 0, that would make the denominator equal to 0, and that's not allowed. So we continue with this pattern. We'll get x is greater than 1, and so possible solutions we will get out of this are, in words, you could say all real numbers satisfying the inequality. Satisfying x greater than 1. Again, you can use set builder notation, the set of x such that x is greater than 1, or you can also use interval notation and do 1 to infinity, provided it will write for me. There we go. And there you go. Everything you need to know about domains and radicals.